Good morning. Today we're looking at 3 problems for momentum. These problems are going to be the same problems that are on Thursday's test, except I'm going to change up the numbers. So if you pay attention to this and you write them down, you can use this on Thursday's test. You should get 100%, ideally, but I'll be pretty lenient on my grading. So here we go. Number 1. 2 train cars at rest in an abandoned train yard. When a stick of dynamite is placed between them. When the dynamite explodes, the heavier of the 2 train cars moves left with a final velocity of -3. What will be the final velocity of the other train car if it has a mass of 8,700 kilograms? For all these problems, we're going to use the same equation, just in slightly different ways. And it is this equation, the one that starts with m1 v1f plus m2 v2f equals m1 v1o plus m2 v2o. That's the equation we're going to use for all the problems on the test. The unique thing about this problem is that both of our initial velocities are 0. As it's stated in the problem, and as we see in the picture here, they're at rest initially. So that means V1 initial and V2 initial are 0. So these 2 terms are going to cancel out entirely. They gave us everything else we need to solve. So M1, it's written right here, is 12,300. M2 is 8,700. V1F is -3, it says up there and it says here, and we're trying to figure out V2F. So this is a pretty easy problem because of that cancellation. Let's plug it all in. So we have 12,300 times -3 plus 8,700 times V2F. We got 0 on the right-hand side. I'm going to subtract 8,700 V2F on both sides. I'm also going to multiply this, 12,300 times -3. So we'll get -36900 equals -8700 V2F. And now all we have to do is divide both sides by -8,700. And we'll get it'll be positive. We'll get positive 4.24. So V2F is 4.24 meters per second. The reason it's positive is because car 2 is moving right. Also, you'll notice that it's more than the other. So this is going to be 4.24. It's a larger number than this because this is lighter. They're going to have equal momentums, but that one's faster because it's lighter. It moves farther and faster because of the explosion. Let's go on to number 2. Again, you'll be able to use that on the test. You're going to have different numbers though. Number 2, in a game of pool, the white cue ball has a mass of 0.17 kilograms and is moving with an initial velocity of 1.8 meters per second. The cue ball strikes the 0.16 kilogram 8 ball and stops completely. If the 8 ball starts at rest, calculate its final velocity. So in this problem, we have a couple of zeros, just like we did in the first one. We're going to use the same equation too. M1 V1F plus M2 V2F equals M1 V1O plus M2 V2O. So there's our stuff. M1 is, we're going to say this is M1 and that's M2. So M1 is 0.17, M2 is 0.16. And let's figure out which our initial is. So this is V2, this is number 2, and this is number 1. So V2 initial is 0, because that starts at rest. Let's cancel out a term there. So V2 initial is 0, because ball 2 starts at rest. And then at the end, this cue ball is at rest. So the difference between this and the first problem is that one of our final velocities is 0 now. So M1 final, or V1 final is 0, because ball 1 ends at rest. So since it's at rest after the collision, V1 final is 0. Once again, because of these zeros, we have a nice, easy problem to solve. M2 is the mass of the second object, so that's this one, be 0.16. We're trying to figure out the final velocity of object 2, so we'll leave that in there. M1 is 0.17, and V1 initial is 1.8. Oh, gotta show that work there. Should simplify, take 0.17 times 1.8, 0.306. We'll leave the 0.16 in there. And now we just divide both sides by 0.16. So V2 final is 1.91. Once again, the second object is moving a little faster because it is a little bit lighter. So 1.91 will be our velocity, our final velocity for the cue ball. I think I underemphasized something in this problem and the first problem too. Like in any conservation momentum problem, you have to name the objects. So this is object 1, this is object 2. We'll do that in the next problem with Granny and Ricky. This little fold. Okay, so last problem that we'll have on the test is Granny and Ricky. Granny, who's 80 kilograms, is rollerblading at the skate park when she sees that her grandson Ricky is about to fall down, and Ricky is 40 kilograms. She races over with an initial velocity of 6 meters per second and lifts him up. Calculate the final velocity of Granny and Ricky as they roll off together. So I'm gonna name the objects here. We need to assign 1 to one of the objects, and we need to assign 2 to one of the objects. So I'm gonna say that Granny is number 1, just because she's on the left. I know it's a weird reasoning. Whoop. She's number 1, and then Ricky is number 2. And I can do that over here. Since they have the numbers in the picture, may as well organize it that way too. So all the numbers over here are our initial values. All the numbers over here are the final values. So M1 is 80, V1 initial is 6, M2 is 40, V2 initial is 0 because Ricky starts at rest. M1 final is, well, it's still 80. V1 final is unknown, M2 is 40, and V2 final is also unknown. So the tricky thing about this problem is we have 2 unknowns, but we'll find out in a second that it's not really true. We don't really have 2 unknowns, it's just 1. Once again, we're starting with the conservation of momentum. There it is. Let's find our zeros. You could probably guess by now which of those is 0. It's going to be V2 initial is 0 because Ricky is object number 2 and his initial velocity is 0. V2 initial is 0, cancels out that whole term. Although we have 2 unknowns, the trick I'm going to show you, the little trick I'm going to show you is easier to see when we plug in the numbers. So we'll go ahead and plug in the numbers now. So M1, that's Granny's mass, it's 80. 80 V1F plus 40 V2F equals, so M1 is 80 and V1 is 6. So here's the deal. 80 times 60, I guess we could solve that part right now. It'll be 4,800. Oh, it's just 80 times 6. So it's 480. Yeah. And here's the little trick we're going to use. So right here, V1F and V2F are actually the same number because Granny and Ricky are moving off together. So their final velocity is actually going to be the same. So what we're going to do is we're going to distribute out those numbers. I'm going to make a little intermittent step here. I'm going to change this to just call it VF because V1F and V2F are the same number actually. So instead of differentiating between 1 and 2, we'll call them the same thing. 80 VF is what I mean, plus 40 VF. Those final velocities are the same, so why give them different names? Just call them the same thing, final velocity. And as we see here, it's just 80 VF plus 40 VF. Well, that's 120 VF. Equals 480. We'll divide both sides by 120, and we'll get our final velocity. And I feel the need to check that. $480. Yep, that is correct. So there you have it. We have 3 problems. Again, on Thursday's test, it's going to be the same 3 problems, so it's pretty easy. I need to give you something that's going to be graded for credit. Wow, that was pretty fast. Hope you paused a little bit so that you can think about it. Don't just fly through and understand it. I mean, make sure you understand it. If you have any questions, let me know. Again, on Thursday, just different numbers for this. Thanks for watching. Have a good day.